very glad you've joined in. Finally, right, okay. So I think while we were getting going, we established that not everyone in the room had seen ChatGPT and what it can do, but a fair few had. So I think what I should do is start at least by giving you a demonstration of what it can do, which is somewhat frivolous, but I think has some lessons inside it. Each year, a number of us get together for Burns Night, which happens in February, and it's a celebration of the great Scottish poet Robert Burns, who has produced a huge corpus of poetry, celebrating all sorts of things like the flea and the mouse and the haggis. And when the haggis is produced at a Burns Night supper, this poem is read. Now, the enterprising butcher called Simon Howie in Scotland decided, as a way of maximising their profit, they would produce a chocolate haggis this year. And I thought, well, how fitting to produce a poem in the style of Robert Burns to celebrate the chocolate haggis. I thought I could do that, but I thought actually that's going to be quite hard work. So why don't I try ChatGPT? Well, I said, write an ode to the chocolate haggis in the style of Robert Burns. And this is what it wrote. I'm saying it's not he or she. The program produced this. And it's really pretty good, but it's a bit odd in some ways. Upon the brawny table laid, a feast of oddity displayed, a haggis made of cocoa sweet, a daring twist, a tempting treat. So it rhymes and it scans most of the time. Oh, chocolate haggis, rich and rare, in Burns's land a culinary dare. No neeps or tatties by its side, but cocoa beans in sweetness by. With every bite, a rich surprise, a Highland melody in cocoa guise. No bagpipes play, no tartans worn, yet chocolate haggis, a feast reborn.
My goodness.
So here's to thee, this darling dish, a modern twist, a chocolatey wish. In Burns's spirit, let all partake of chocolate haggis for Scotland's sake. That's pretty good.
No timorous beasties, though.
No timorous beastie. It's not as Scottish as Burns would have been, but it's a remarkable piece of pastiche. And I think that's one thing, and that's really all that ChatGPT does. It sucks in Burns's corpus, and it produces, on the basis of that, on the basis of some hints, something which is in the style of Burns and is about a chocolate haggis. So it's plausible pastiche, if you like. And I think that's one way of looking at what. Don't think about. Perhaps I'm nailing my colours to the mast here, but one position on this kind of generative AI is that this is what it does. It's plausible pastiche. It sucks in lots of information. It does statistical analysis on that information and generates things according to that fit certain kinds of prompts. But it's not got no sense of right or wrong. It's got no sense of person. So one analogy, I mean, you might not want to think about this, but one analogy is it's a bit like Boris Johnson. You ask Boris Johnson to write an essay, and he'll produce an essay, at school, which will probably fake a few references and so on, but it'll be pretty good as a first stab at an essay, because he can pull in. He understands how to write pastiche. He understands the style he's trying to adopt. You put some facts in and so on. So I think it's important to think. It's important to realise that this is one way of looking at it. Just lower your expectations to what it does well, to that kind of Burns pastiche. So what I want to do now, that having sort of set the scene, is perhaps roll back a few millennia and just try and think about. I think this context is important because I think part of the hype about AI is around the fascination that we have with artificial life. It's something that has fascinated people through the millennia. There was a bronze giant, maybe just not a giant, but a bronze man that protected Crete against pirates and invaders. Back in the many millennia before the Christian era, or Talos. So thinking of there being creatures which are different from ourselves, have been manufactured in some way, is something that has been a fascination and is still a fascination. Fast forward a few millennia to this, from the 18th century. It's an absolutely beautiful, compelling look at the video on YouTube of a mechanical swan and it's not a static swan, it moves, and the way it moves and dives its beak into the water is absolutely compelling. And there's something in that makes us, that's fascinating, I think. So I think there's a reason that people get excited about AI. And people have been doing all the things that are perhaps more like human life. There was this famous mechanical Turk that could play chess, and there's lots of interesting analogies and things come out of that now, and I'll talk about some of those later on. It was a con. It wasn't, the machine was not playing chess. There was a little person inside playing chess. The little person had to squeeze inside this tiny space. It's a hugely ingenious mechanism, but what the fascination was not it was a mechanism with a person inside. It was meant to be a mechanism with no person inside and just this mechanical human. So I think there is real fascination with artificial life, but there's also worry, and I think you see this, and these sort of ideas are playing out now in the sort of apocalyptic scenarios that we're hearing about AI. That will it be the end of civilization? And I'll talk a bit more about that. So people, it's fascinating to think life could be created, but it's also scary. It could have terribly negative consequences. So people have been thinking about artificial life for as long as history has been recorded, almost. But more recently, people have been thinking more specifically about machine intelligence, artificial intelligence, trying to put intelligence inside computers, digital computers that we build. The reason I put this picture in, this is the baby machine from Manchester, which was arguably, we're in a British environment, which is the world's first stored program computer. There are disagreements about whether in fact it was, but it's certainly one of the first. And it was built in Manchester, and there's a fascinating story, again, not on the topic of this presentation, about how they built a replica of it 50 years later, and how contingent it was on having photographs like that to be able to identify the valves that were used in the actual machine. But we're not here to talk about that. The reason I put this in is because it would have been used by Alan Turing, and we can't talk about artificial intelligence without talking about Turing. And I think one of his key, if you read his papers about this, one of his key insights was, and he took a particular view, and it's not the only view that people have had of AI, but he took the view of, well, observe the system. Don't think about how it's producing an effect, but you can judge a system, or you should judge whether a system is intelligent or not. To paraphrase, if you can put inside one booth a computer, inside another booth a person, you pass questions into those two booths, and observing the answers, you can't tell the difference between the person and the computer. He also had a line about having a man and a woman, whether you could tell the difference between a man and a woman by the answers that they gave. But what he was concentrating on there, and I think he says explicitly in one of the papers, that he doesn't want to try and define intelligence, because that's a difficult problem. But what you can do is say, can this device successfully imitate intelligence? And so that's, you can argue that if it can, that is one definition of artificial intelligence. And I think it's a good one. It's a better definition than many of its successors, I think. So that one view is it's building machines which can behave in a way that's indistinguishable from a human. Now, of course, this isn't embodied intelligence. These people are the person or the computer are behind a screen. You're passing back questions on pieces of paper or whatever. So it's all about language. It's all about, just as ChatGPT is all about language. And arguably, and for lots of people, intelligence, and the sort of intelligence we have is embodied, and that makes it an entirely different kind of thing. So Turing's definition is of only one kind of intelligence, I would say, but it's still a good one. So really, I think you can see that there are at least three schools of AI, I think, that are in play at the moment. I mentioned the embodied intelligence, and so the whole way that robotics combines, you have a device which receives stimulation and then produces actuation. It acts in the world, and so that's one area that people are looking at. Another, the Turing one, is this idea of behaving in an intelligent way. And the third one, which I think Turing was explicitly not wanting to address, is trying to think about modeling in a computer the way we actually do think, which is broadly cognitive science. So what is going on there is that people devise, and I think probably it's not unfair to say overfit computing models to what goes on in the brain. I mean, someone like Jerry Fodor was writing in the 1970s about the brain being procedural, which is just how computers how programs and computers happen to be in the 1970s. But people are trying to replicate the way that the brain works inside artificial devices. And I really won't say anything. I won't say anything more about that. I mean, it's a fascinating area. But for the rest of the talk, I'll concentrate on this behaving intelligently in some way. Hope that's okay. Can't talk about everything. Yes, and there are interesting things to say, but what's nice about the Turing, and I think right at the start, making that distinction is very helpful, because it says don't worry about how it does it, but worry about it doing something that is recognizably human. So what's it mean to behave intelligently? And that's not a stupid question, I think. Computers have been doing better than us at lots of things since their inception. Computers are better at doing arithmetic than we are, and they have been almost since they were produced. But I don't think people wouldn't say that that was a sign necessarily that a program isn't intelligent because it can do calculation, arguably. So I think it's one of the things we can do, but it's something that a machine can do without us thinking that it's intelligent. Perhaps closer to what we think of as intelligence is getting computers to do things like algebra, solving equations, not solving equations numerically, but doing the sort of algebra we learn in secondary school. That's primary school and secondary school. That's something that computers can do remarkably well. And now we're getting to the point where real mathematicians are using computers as assistants to producing new pieces of mathematics. And that's something really that's only happened in the 2020s. Up to then, people were using computers to write proofs about essentially not very interesting things. Now that has changed. So now computers can not necessarily not discover, but they can be pushed to reason about things in a way, reason symbolically about things which are which are mimicking the way that that we reason. And this perhaps points to a crucial distinction, another of the key distinctions I want to get across. This kind of discussion is about symbols. It's about mathematics. You have variables and you do things with them, and equations and so on. It's about tangible, again, things that are a bit like language. But there is another side completely to the way that we behave as individuals, which is subconscious, below that level of symbols. And that's something that I'll come to a bit later on. But coming out of this theme of trying to mimic intelligence in a way that we do it, so thinking about calculating and reasoning, something that became very popular in the 1980s and through the 90s was this idea of building expert systems. And it's a funny sort of paradox that it's not a funny paradox, it's a very clear paradox, that it's easier to mimic an expert than it is to mimic an ordinary individual. Oh, sorry. It's easier to mimic an expert than it is to mimic an ordinary individual. It's easier to perhaps to encode the knowledge that a diagnostic physician has than to encode the knowledge of the person who comes in at night to clean around the surgery and so on. Because that second process requires all sorts of sensory information. It requires common sense to understand there's a chair in the way, or somebody's left a cup of water. There's a cup full of water on the table. Things like that, which are obvious to us as sentient humans, but not obvious to a program unless it's been programmed in a very complicated way. Whereas making a decision perhaps about whether somebody has a particular kind of cancer or another kind of cancer can be codified in symbolic rules that say, given a certain set of observations, this is the diagnosis. Now the problem with that was, through the slide, I put two things on here, but just sticking with the expert systems for the moment. The problem with that, in practice, it was never easy to get the rules right. You could get a set of rules, they weren't quite good enough, so you needed to add more rules and exceptions and so on, and then maintaining those sets of rules as things changed proved to be completely infeasible. So they became brittle, if you like. They were hard to maintain. You could start off with something that looked as though it was good, but in the end it would degrade and simply be useless. And so I don't think you hear about expert systems. The last 20, 25 years, it's simply not been a thing that people do because they didn't work in practice. There was a big push in Japan, the fifth generation project, huge hype in the early to mid 80s, which set this going and really got things moving in the US, Europe, and all over. But as I say, it didn't pay out in practice. There had been, before that, there's and YouTube is wonderful. It's remarkable what you can find on YouTube. James Lighthill, who's a mathematician, was asked to write a report on the state of AI research in the UK. And he wrote this around 1973. And he was absolutely scathing about what had been done. And this was partly, there's a lot of politics. There was a group in Edinburgh, a group in Sussex, and there was politics between them and so on and so forth. But you can actually see some of the hearings that he did in public on YouTube. And he is absolutely scathing about what the AI researchers were doing at the time. And this was particularly in the area of machine translation. And he said enormous sums have been spent with little useful result. And that meant through the 1970s in the UK, there was almost no funded academic research in AI. And it's interesting that in this case, the work that was being done was basically at the symbolic level. It was Chomsky had a huge school in a huge research group in MIT, ironically funded with naval defense money, where what he was trying to do was build grammars that would enable machine translation to be built. And so his approach was very much one to processing languages as symbolic things. You have a grammar, you can process what someone is saying, you can then translate it through a universal grammar or whatever. But that basically didn't work. And where we've got to now is this, what we see as a symbolic. The sub-symbolic approach has taken over in terms of machine understanding. The way that programs like ChatGPT are written has nothing to do with finding a grammar in the utterances that are made and building a symbolic representation of the knowledge of the knowledge that's inside those. It's simply a matter of doing statistical analysis on large amounts of data. So this distinction between the symbolic and the sub-symbolic, and I think affectionately or scathingly, the symbolic gets called good old-fashioned AI. It's what people used to do, but now they don't do it any longer because it's not solving problems of the scale or complexity that other approaches are. So symbolic, as I say, it's inferring. The statistical methods are essentially inferring parameters in very complex models, and using those for classification, where it's very successful. And now we're seeing it in things like ChatGPT for generative AI. It's intelligence grounded in training. Interesting. If we think about how we've learned to use language, it's not like ChatGPT. We do learn language, but we don't learn it by being exposed to a corpus the size of which would dwarf the library in this building. We learn with a very small training set. So I think, and this is still a very live question. I'm not technically qualified to pronounce on it, but it seems to me that we are not LLMs. We're not large language models. There is something else going on. And this was the line that Chomsky and the symbolic people were taking. So there's clearly something going on between the symbolic and the sub-symbolic if you're looking at human intelligence mimicking that. So where we're talking, the AI we're talking about, the AI that's getting the buzz, is this statistical based, and the mechanisms are loosely based on neural behavior. I think it's probably better not to think about that, because that makes you think. I think it biases the way we think about it. It sort of anthropomorphizes what these learning programs are doing. I think it's probably better just to say it's machine learning, which is based on inferring parameters in large models. And one thing that I think is going to be one of the big challenges is that it's short on explanation. Typically in the symbolic world, if you ask, why did you give this diagnosis of this cancer rather than this cancer, you can say, well, these rules fired in this way. Here's an argument. In the sub-symbolic world, well, it's just the data says. I trained on 1,000 or 10,000 images to distinguish between this and this, and it falls on this side. But there's no direct explanation. It's simply buried down in the data. And I guess I'm skeptical about us producing explainable AI, but I'll throw that out as a challenge. Okay. So neural networks are one way of inferring values for parameters. Let's not think about that. But they've been tremendously successful, and I think have achieved human, if not better, performance in doing classification and things like classifying tumors in pathology and so on. That they are things which can be used quite regularly. So I think in terms of pattern recognition, vision of certain kinds, I mean, this kind of problem of identifying cells in a tumor is, or distinguishing between different tumors, is quite a different problem from producing the analysis of camera, real-time camera data from a car that's moving on a roadway. You know, these are, you've got clear distinctions, you've got large amounts of training data, you've got a very controlled environment. So, but in those cases, things seem to work very well. One of the things that I wanted to stress, because one reason AI is tackling much bigger problems than perhaps it did before, is just because machines have got faster and bigger. One reason that AI, we're talking about AI at the moment, is that Moore's law has meant we can build machines of this kind of scale that produce, that consume huge amounts of electricity, and build the parameter sets, infer the parameter sets in these large models based on huge amounts of data. So maybe the mechanisms don't have to be hugely more successful or hugely more subtle in order to get lots of advantages. You know, computers have just got, and for that we've got to thank electronic engineers. I think they have done remarkable things. But in the last, I think I was wanting to move things forward a bit. So in the last 10, 15 years, some real barriers have been passed. Chess was cracked quite a while ago, but cracking Go so that a computer could play Go with and beat the best human players was certainly was a remarkable step, I think, because the number of potential configurations there are in Go is astronomical. It's very large in chess as well, but it's a much less structured game in a way. And to be able to infer from training data successful ways of playing is clearly, you know, that's a very big achievement. Now it's working within a model where it's clear it's a simple world. It's simply described, but of huge complexity and huge subtlety. And I think in order to see that has been a real achievement for AI. I wouldn't, you know, I'm not here to rubbish AI at all. I think I'm just here to try and get some perspective on what's worked well and what hasn't. As I understand it, and this is not it's not a professional insight, there has been a change, and I think you can see that the technology for doing for building models has changed with the arrival of transformers, which, as I understand, at a very high level, allow us to model context in a way that means you can produce, both in analysis and generation, things which are much more like the things that that humans can do. So being able to understand context, you know, context is everything really, and you know, you can, like in language as in lots of other things. So transformers, and that's the T in GPT, generative pre-trained transformers. So there has been a technical advance there, and that's what we're seeing in these recent models. And just looking at language, the way that Lighthill in the early 70s was saying, you know, language is not, there's been very little progress here. It's remarkable how much now we take for granted. And there's always people in AI say, one of the frustrations of working in AI, as soon as you've really solved the problem, it stops being AI. And I think that's the case now with things like speech synthesis. That's, I think we take for granted that works pretty well. And you know, sometimes is it recorded or is it pure synthesis? It's not clear, particularly in announcements on a train or something like that. Recognizing speech, similarly, I routinely use dictation on my phone, and it's not perfect, but it's good enough to to ease my thumbs or whatever. If I want to write a long email on my phone, I'll dictate it and then correct it. And that seems to, that's just something we take for granted. I think machine translation is happening as well. Routinely, I use Google Translate. So these tools are coming. And language generation is there. So what about ChatGPT? I said I would discuss that. What on earth to make of it? Well, there is this there's the hype curve. I don't know if you've seen this. It's a wonderful description of the way that technology particularly can be seen by, I don't know, is perhaps seen in a cynical way or just the way it gets perceived by, that there's a peak of inflated expectations about what the technology can do. And then when it can't do that, of course, there's a trough of disillusionment. And then there is a slope of enlightenment and a plateau of productivity. And indeed, the question, the interesting question is, what is the slope there? And does it ever stop? How high is the plateau above the trough? We don't really know yet, I think it's too early to judge. So lots of people are still at the point of inflated expectations, and they would do because they've invested hundreds of millions of dollars and hours of training time in saying precisely that. Other people cannot be convinced by anything, but I think where are we? I'm not sure I think maybe we're around here and moving up there. It's hard to tell. There's an interesting analogy with just trying to predict technology or predict how technology is going to turn out. I don't know. I guess nearly everyone's familiar with 2001: A Space Odyssey and HAL in there. When that was made, Stanley Kubrick and Arthur Clarke put in a huge amount of research through the mid-60s in trying to predict how technology would be in the year 2001, and they did a very, very good job. I don't know if there's a very nice book. What's its name? I can always send it out afterwards. I'll put it in the slide, which talks about the science in 2001 and how things turned out as in line with the predictions or not. And there's a lovely bit in there where Arthur Clarke and Stanley Kubrick went to Bell Labs and they saw a computer doing very early speech synthesis. This would be about 1965, so 60 years ago. And the computer sang Daisy, Daisy. Daisy, Daisy. I don't know if you remember in the film, when Hal gets taken apart, they start pulling his memory out. And the last thing he does before he lapses into silence is sing Daisy, Daisy. So there's that wonderful, they thought very hard about, doing the prediction, but they didn't get everything right. What's wrong with this? Wings? No, the wings are fine. It's a bit like the space shuttle. This is flying up to the space station in 2001. Pan American was a world famous huge airline in the 60s. It had gone bust by the 80s. So it's very hard to make predictions that will stick. But let's see where we are. I think it's clearly here to stay. We will be using ChatGPT. Here's a lovely reference. It's an online questionnaire, and I'll give you a copy of these slides which have the links in them, so you can stick them on the web.
Yes.
Yeah, fine. And it's a challenge. It asks you to rate whether or not ChatGPT can tell you something. And it's getting you to try and think about what it can do. And then you can see whether it does or not. And it's remarkable how, I think, I think one of the oddest results you get from it is that it can't play noughts and crosses. Or when it was set up, it couldn't play, but it could write a program to play noughts and crosses. Now, sorry.
It's a very bad program.
It's got some oddities, and the more you play with it, the more the odder it can seem. So that's well worth taking a look at, and see what it can do and what it can't do. And there's a nice Financial Times article that goes with it. And I guess one of the things that you will have heard about is just that these programs can hallucinate. I think a marketing guy or man or woman got into that. It's not hallucination. It's just wrong. This idea that so these things are based on, I think the story that maybe I'm just a Luddite, but these things are based on prediction on the basis of models that have been inferred from the existing data, and some peculiar things will come out of that, particularly if you generate lots of things randomly, then, or with random inputs, then things will turn out in a peculiar way. A classic is you need, if you ask it to write an article with references, then it will produce, or can potentially produce, fake references. Maybe by real authors. I read something of someone saying, I wish I had. I would really like to have written that paper. I just haven't. So perhaps the crucial question for each of us is when does it make sense for us to use AI? I think, and if there's one takeaway, I think this is the bit that I feel most strongly about. I think my answer is that you ask, where is the human in the loop at the moment? I think there is, and let's explore a few examples of that. So speech recognition, that's fine. I can, if I talk to my phone and it writes out what it thinks I've said, it won't always be correct, but it's easy for me to check. I can see when it's got something wrong, and I can easily correct it. So I'm in the loop, and the cost benefit is in favor of using it. So that seems like a really clear-cut situation. I spent some time teaching at a university in Hungary, and my Hungarian is almost non-existent. So I use Google Translate to do translation for me. Now is that a reasonable thing to do? Because I can't really check it. But actually what I can do is I can feed it back in. And so the rain in Spain falls mainly on the plain, which scans nicely. In Spain, it mainly rains on the plains. That's fine. That's correct. So again, in that sort of situation, I can do some sort of verification. And if what comes out at the other end is garbled, then I've got much less faith in what was there in the middle. The garbling might have been in going from English to Hungarian or Hungarian into English, but it's happened somewhere. So that's problematic. Now, what about when we get into coding? How many of you are using something like Copilot in coding? 2, 3, 4, 5, 6, 7, quite a number. Okay, I used it, and it's surprisingly. I wrote a first-year textbook, and I'm on functional programming, and I'm revising that. It can solve many of the exercises in there. Now that's perhaps not surprising, because I'm sure, as I might say later on, I'm sure it pulled in the text from somewhere and trained on it, but without acknowledging or paying me. And also these are very small programs. So putting in a small, and this is Haskell, where the type of a function gives you quite a lot of guidance about how it will actually behave. And perhaps I thought with this, there's a function that takes a list and removes all the duplicate elements. So you just have one occurrence of everything, of each element that's in there. And there are two algorithms. One keeps the first instance, the other keeps the last. The one in the standard library keeps the first, and I thought, oh, I'll write the one that keeps the last. And that it got to, I think I got to, yes, you can see here, I got to writing if member X X's, and then everything else here was produced by Copilot. And I thought, oh, maybe that's because I called it my nub, so it knew that that was, but if you call it F or whatever, it will do the same. Now that's partly because of the type, and partly because of the test I'm making, and there are other functions of that type, but it's just, I guess it's seen enough pieces of code that do that to make first-year programming exercises doable. I have a colleague working in industry. I was talking to him, and he works again in Haskell, and he does a lot of reviewing pull requests, reviewing substantial changes to code bases. And he was saying one of the things he finds really improves his productivity is to use Copilot to summarize code. He's then got to read it, and Copilot doesn't always get it right, but it's a really useful line in to understand it. And this is a nice summary. I've written a function which it's not terribly exciting, but it runs along a list, and if a number is even, it duplicates it, and if the number is odd, it leaves a single instance. And it says, the summary says, in summary, this function duplicates the even numbers in the list and keeps the odd numbers as they are. That's a nice, so you can see above there, in the section above, it's saying, oh, blah, 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 recursive call, blah, 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 blah. But then it condensed that into something which is exactly what I would have said. So there are, that's a very nice, but again, that's what that's doing, that is doing, and I think many of the uses of AI that we're familiar with are like this. It's taking information and presenting it in a different way. This was a question of trying to get ChatGPT to write something, and this is the point where, not Copilot to write something. This was the point where I could begin to see that things were not working as well as I'd hoped. I'd written a specification, but it wasn't quite clear that it understood the specification in the same way that I did. And so I have to read the code in order to understand precisely what it's done. And so I could have written the definition as easily as getting the AI to write the code and me checking. And just two more perspectives on more serious coding. This is an interesting guy, Nikas Carlini, who also wrote the What Can ChatGPT Do? He's produced a benchmark for what large language models can do, mainly programming problems in Python. And so he's using that as a way of evaluating coding language models as they evolve. And finally, I think a cautionary tale. If you think about what real live programmers do, they take GitHub issues and they solve them. The state of the art is that the best performing model, when put to solve real GitHub issues in real code bases, was 1.96%. It basically couldn't do it because you need context, you need to understand architectural concepts and so on. There's a whole tacit layer in the code which is not reflected symbolically in the code, and what the machine can, all that a learning device like this can do is reflect what's in the code and the comments and so on. But if it's not written down, any tacit assumptions or knowledge or whatever, it's harder to I'm not saying that it's impossible to model those, but this is at the moment the limit of where things are. So it's great at being a first-year student. It's crap at being a software engineer. I mean, that may change. But we may be in a situation like nuclear fusion and self-driving cars, that it's always going to be 5 years out. So I simply don't know. What about education? I think it presents problems and opportunities, as people say. It means that the way that students are assessed will change. I think it confronts teachers and academics with the issue that people, what they see in front of them as a piece of code that somebody has produced or an essay isn't necessarily wholly produced by the person who said it was. But that was always the case before ChatGPT. But I think it's now made that an unavoidable problem. So what can we do? Well, one thing we can do is go back to good old-fashioned exams. And the Hungarian place I teach, just computing exams are done in a room which has no access to the internet. So you have a computer, you can write programs, but you can't consult. And that's one way of doing things. But that's not ideal, but it's a model. I think the other thing you can do is say, okay, let's talk about the solution you produced. I think the opportunity of talking to students more is a good one, and I think that's something we should embrace as teachers. I think it's become very easy, particularly in mass higher education, to think, oh, I've got all this, why you have to do this. Engaging more with students is a potential good thing. I think it's one thing that academics are always getting beaten up about is not giving feedback immediately. If you have a conversation with somebody about the work they've done, that's the immediate feedback. So I think there are real opportunities here, as well as fast feedback. But the problem is, it's like if you did all your learning with Copilot switched on, it's not clear you would learn very much about programming in Haskell, say, because Copilot would be doing so much of the work for you. So how do we find the balance between saying no assistance at all, or embrace it, or there is a point in the middle? And I think talking to academics around the country, which I've been doing on BCS activities, I think people are just struggling to find the right model in the right. There are situations where you can do it very well, and other situations where you have to be more wary. How am I doing for time, Bob?
You'll find you're at about sort of 50, 55 minutes.
Okay, right. So using it's very good at summarizing speech recognition, suggestions. But I think where it falls over are complete artifacts, complete code bases, writing a book, writing a whole project, and what the implicit, the tacit, which libraries do I use in writing this particular part of this programming project? That's where it's simply not producing results that are acceptable. So I've added a few, just to conclude, say a tiny bit about the reception that AI is getting and what's good and bad about that. Everybody's talking about it. All the big consulting firms are trying to sell AI like there's no tomorrow. It's a bit like, to be crude, it's a bit like you suspect it's a bit like teenagers and sex. There's lots of talking about it, but there's not very much is going on because people don't quite know what to do about it. I think companies there's fear of missing out, again, teenagers, but there is how precisely is AI going to make a difference to my company, to the way I work? It's not a straightforward So this is a thing, content from Deloitte trying to sell AI training to, sorry, apologies to Deloitte, is all other, this applies to all other large consulting firms. The jury is out about how precisely it's going to fit in with people's, the things that companies do, the day-to-day operation. And I don't know if you listen to the Today program, this guy who runs AO.com, which is it's the biggest seller of white goods in the country, I think. And he was on the Today program talking about AI on Monday. And he said, yeah, we definitely want AI. We want it to do routing of delivery vans. Well, you couldn't do that with AI from the 1970s. And we wanted to do sentiment analysis of reviews. Well, people have been doing that for. So in one sense, the hype around AI is making people think again about how they automate things in their business, that it may not be very much to do with large language models. I don't think LLMs would be any use at all at routing your delivery vans. They would be really crap. They'd produce a route that was plausible but wrong. They really don't do routing of delivery vans. And he's not stupid. We should maybe take this out of the recording. But I think this is it's a typical example of how much kind of fog there is around the whole question of AI. And all this sort of froth. It's also this is a great illustration of why any headline that begins with a question mark has the answer no. A chatbot that imitates the dead, is that a good idea? No. Is artificial intelligence a solution to cybersecurity threats? No, it's just a source of more. There's lots of speculation. There's an interesting analogy with spreadsheets. I think one of the attractions of a spreadsheet is it always gives you an answer. It doesn't ever say, oh no, you can't do that. But one of the problems with a spreadsheet is that it always gives you an answer. And unless you check it, you can easily give you the wrong answer. So I worry that there is, and there's been a lot of work done on audit. There is now a business on auditing spreadsheets in large companies. And there's well documented examples, like the data that George Osborne used to justify austerity in the early 2010s. The analysis there that if debt exceeded or got close to 100% of GDP, then it slowed the economies down. That analysis, published, was found to be inaccurate. They'd missed some of the key data out, which would have shown there was no correlation at all. And this was published, and so, except because it's so welcoming a technology, people use it and can potentially misuse it. And similarly, I think with AI, that it always gives you an answer, and that's the great thing about it. I got my Burns poem, and it doesn't matter if that's a little bit odd in places, but in other cases, it's serious that it's giving you. So there's a whole question about how people get. I talked about there being humans in the loop and that being a good thing, and potentially, I think that the examples I showed, and perhaps I didn't make the point clearly enough, where something like ChatGPT, where Copilot is working so well, is as an assistant to a human programmer. It's meant to be, it's helping you be more productive by completing the lines of code that you're producing. But there are humans who get pushed into the loop of doing nasty jobs, as they do for some of the big platform. Weeding out and ensuring that LLMs are not producing offensive or criminal or other kinds of output. And that's down to, it's like the poor guy stuck in the machine. It's some poor man or woman sitting on a computer somewhere getting paid very little, being shown offensive things. So there are humans in the loop being used in a bad way. And there is the question about control. A lot of people, Tim O'Reilly, who's a big tech evangelist, has been and publisher, has been pushing on this, that most of these models have been trained on stolen intellectual property. If you've written a book, they've probably sucked it in there and not acknowledged it. So there's that. There are the issues about privacy and dignity, about producing fakes that look like real individuals. And I think from my perspective, I don't think AI is going to, perhaps in some corner cases, it will help security analysis. I think for me, it just seems like another attack surface. It's not, doesn't seem like it's making your systems any simpler or more predictable, or and there's a link there to a story in Wired about, and there are people who take an adversarial approach to particularly things like the analyses in self-driving cars, of being able to smuggle in data into pictures and getting that recognized, even though it's invisible to the naked eye. But the government is coming to our rescue. There is the AI Safety Institute, which is going to do rigorous AI research to enable advanced AI governance. I said that with a straight face. It's a state-backed organisation dedicated to advancing this goal. And it's saying governments have a key role to play. I agree they do. It's going to become an arm's length body, and the government is going to legislate. At the moment, it has informal agreements with the large LLM providers, but it's going to try and legislate, as indeed is the Competition and Markets Authority. But it's hard to think that that's really going to grasp a nettle. It's I don't know. I think I wanted to end on this because it's sort of a BCSE issue. You know, it's about how computers are used in society, and we're the professional body for IT and computing. And I think it's something, you know, it's a thorny question. People are talking about it, explainable AI and so on and on. But I think it's a major issue. No. But anyway, at that point, I will stop. Oh no, I was going to say yes. Okay, sorry, I've got more slide. And this is, I don't believe the apocalypse stuff. I think it's the enshittification is the thing. You know, I'm not sure if you've heard that term, but it's about how platforms get worse. They start off being great and they finish up being crap in a technical term. And I think AI is going to contribute to the general enshittification of systems that we use, rather than being a massive apocalypse. But that's just my personal opinion, and I'll leave you with that. Thank you, Paul.
Thank you, Simon. Quite interestingly, we learned about enshittification last month from Ron, didn't we? So right. Yes. So we can take questions. I've got just one question that's come in over the chat. There have been comments in the chat as well, and what I will do with those is I'll try and get the chat log actually up on. It's not very long.
Okay. Yeah.
Up on the web page as well. BCS failed to do it last month, but I think they didn't quite understand what they should do, to be honest, because the rest of it goes onto YouTube.
Right.
The question we did have was, is this like the orca recognition AI, essentially comparing thousands of photos? Because it doesn't really think it's AI. You heard of orca recognition?
No.
I haven't either, no.
It was in context with the presentation slide that you had available there.
There's always a question about what AI means, and you know, when a technology becomes routine, then it stops being AI.
Yeah, I mean, to me, it's always meant machine learning and things like that.
Yes.
Back in the day, anyway. So we take questions. We have a microphone which may or may not work. So if anyone's got a question, we can come around to you with the microphone.
Right, thank you, Simon. Really interesting. Lots of questions. But I just would like to start with one, because I'm guessing people have used it. So
a bit nearer.
So you particularly first, and then the audience. I'd like to know, are there any careers that you would advise your children or grandchildren not to go into?
Marketing.
And it's before AI.
Well,
Because of AI, yeah.
But I think, I mean, marketing seems like write 500 words on X. I can, in a yes. Though people who do marketing would say it's not marketing. That's not marketing, but I'd be people who write bits of code, bits of text for money.
Any of the audience got any thoughts from using it in their own jobs? Okay.
Anyone else?
Oh yeah.
Just to follow up on that, sometimes when you read the apocalyptic stuff about AI, I feel rather like a weaver who's just retired in the 1820s, wondering, well, what's going to happen to my kids and my grandkids. How big a threat in that sense is AI to jobs? So they're saying things like you don't need doctors, you won't need lawyers, and so on. You will need carers. But,
Arguably, you could say it hollows out the middle. It maybe hollows out clerical jobs and so on. So the typewriter meant the demise of the clerk, and the electronic computer meant the demise of the person, as the human computer. But it's interesting, the article by Tim Harford about Excel, saying Excel didn't kill accountants. Excel meant there were more accountants. So because new things came out of it. So there could be, and you can see there is now the career of prompt engineer. And you can do courses in prompt engineering about how to engage with LLMs. Whether it's so new things could arise.
I don't think you can do anything until you can trust its results. That's the problem.
Human
you
in the
can't
loop.
trust its results.
Yeah.
I asked it to do, my great-great-grandfather was a folk singer called Joseph Taylor in Lincolnshire, was captured by Percy Granger, and I asked for a biography of him. It's full of lies, because he'd obviously pulled in all these other things.
Yes.
I thought, well, I mean, we know that you could become president of the USA by lying through your teeth, but I mean, this is not really what...
Yes.
Until you can trust it, it's useless.
Yes.
I mean, really, to be honest.
But on certain areas, like you talk about prediction, but has it made major breakthroughs in things like weather, where predicting weather and whether that's, I mean, that can be generally helpful, can it? And then maybe it could be a bit more accurate. Well, with more information, it could get probably a better idea than Kubrick's research on doing that, because it can do, obviously it's got far more power to have the research show. Obviously it's not going to be 100%, but I mean, there can be some genuinely useful things from it that we don't know yet.
I mean, I think I would go back to the point that Peter reiterated. If you're the human, if you can work out whether it's true or not, it didn't cost you very much to get that and to see that it was wrong. And in some situations, it will give you information. And I think Google now has started putting a sort of AI summary when you Google for something, which is sort of okay, but it's maybe better than going straight to verse 2 or 3. I'm not sure it is at the moment. But I think if you can tell, if it will do something and you can tell whether the result is correct or not, that's great.
Yeah.
I did a trial of some exam questions I had to look at, and it can do exam questions, but then unless you work through all the working of the exam question, you're not sure it's done it exactly correctly. So again, because it can fake.
Thank you
for
a very interesting panel. You were talking about the hype cycle.
Yes.
And you sort of touched on the idea that maybe we were tending towards that. I think it was called the slope of enlightenment. And I was wondering what kind of examples make you think that maybe we are on that slope upwards, and whether there are things in your crystal ball that you see that would lead us more up that slope.
I think the code assist, I think Copilot, that is very helpful. If you turn that on, it will allow you to write things more quickly. Was my contention, and in things like code review. So there, that seems to be, but it's there. You're in control. You are writing the code. You're doing the code review. It is helping. I think that way around with the person on top, as it were, and the tool of what it's a tool which could increase your personal efficiency. Think of scenarios like that. I think is the whereas unfortunately, you can imagine that companies will be thinking, how can I mean, they need to make money, and so how can they reduce costs? And maybe installing a chat assistant or something like that will help them deal with customers more cheaply or more effectively. It will probably help them do it more effectively, but I don't know if you talk to an automated chat assistant, those are not enlightening conversations because you're so I think places where people might think there will be, because those assistants are trying to replace people rather than enhance the people who. So I think that's where I would see the slope of whatever it is, enlightenment. Yes.
I spend quite a bit of time helping people with complicated database queries. And
yeah.
I find that working through them, whether I'm doing it by myself and going back to them, or whether I'm doing it with them, really helps us to understand what it is we're trying to do.
Yeah.
Quite often at the beginning, we don't really understand what we're trying to solve. So, I suppose this is a statement rather than a question.
Yeah.
I'm interested in whether you agree. So, do you think that using something like Copilot would actually help us with that?
Well, I think you're in charge, so maybe it helps you write candidates that you put in front of the person you're working with. It might make your conversation more effective, but it's still the crucial thing is your conversation, not the tool. I think.
And it's I think what often happens is that at the beginning we wouldn't be able to ask Copilot the right question.
No.
We're dealing with a very complicated, unnecessarily complicated proprietary database.
Mm-hmm.
It doesn't do things the way you expect. Right?
Yes.
So I find it hard to see how that would work. Maybe I should try.
I think the more context and the more, sorry, yes.
Yeah, my question was just sort of around Copilot and sort of gone over some of the history of existing machine learning, etc. sort of things like similar. I see Copilot actually as being sort of like a building block on top of IntelliSense that existed before. Doing the boring bits, sort of filling out the for loop for you, and then you can do the more fun, actual stuff. So my question around that was, I guess, to do with like this hype curve. I wasn't old enough to remember the advent properly of IntelliSense and what people were saying then. But what was the hype curve kind of around that, if you do remember? And were people worried that they were going to lose their book to this, or not have to have hundreds of books and read them on shelves anymore, etc.?
I think ever since I've been in computing, people have been talking about programmers becoming. I remember reading in the early 80s about the end of the programmer. They're going to be fourth generation languages. So I think I see no sign of that at all. So I don't think. I think what's different about IntelliSense is that it's analytical, it's symbolic, typically, that you can do very sophisticated analyses of what a program is doing, and predict an error or predict something that somebody might want to do. That's entirely different from these large language models, which are just based on reading lots of stuff and doing predictions on the basis of that. So I think there's a fundamental difference there. And these things, the famous paperclip that was clearly a masterstroke in how not to market something, because that was really not helpful. So I think these things are. It's hard to predict, but I think it's again with Copilot, it's keeping it in a position where it's almost without you having to think about it, whether or not something is correct. My contention would be, as soon as you're spending a lot of time thinking, is this correct? What's the model under this? What's the algorithm underlying the code that's been written? that's the point where the Copilot is not useful, I think, because you need to be in control of, well, I think, in control of the algorithm, and Copilot will help fill in some of the non-essential details.
Sort of boilerplate, boring stuff.
Yeah, boilerplate, precisely.
I'm afraid we need to bring this to a close right now, I think. Yes. So, thank you very much to Simon for an excellent talk. I do apologise for the sort of hitches, particularly for the people online. This is only our third hybrid meeting, and as I was saying to Simon earlier, everyone is different in the way it needs to be set up, whether somebody brings a laptop, doesn't bring a laptop, what they use for presenting the slides, and a few other things. And we just had a new one tonight because I chose to use a different browser. So that's various things. We're getting there, was all I can say. And I'm sorry for any irritations you may have had. We will keep the chat log, as I said, and there's some interesting observations in there, and a link to the Orca AI as well, which has just come through. So thank you very much, everybody. And next month we have another meeting, which is about ethics and open source. More details on that can be found on the usual web page, and I'll be sending around some links very shortly anyway. Thank you very much, and thank you, Simon.